Okay. So, let us continue with a remaining unit of module 2, the last unit of your syllabus. We have already studied one unit, that is stick diagrams and lambda based rules, as a part of your module 2. You have another unit which needs to be studied, that is your basic circuit concepts. Let us start with basic circuit concepts. In this video we are going to study two concepts here, that is RS and CG. RS is nothing but your sheet resistance and Cg is your capacitance, gate capacitance. Okay. We are first supposed to derive for RS. See, as you are all aware that your MOS is nothing but metal oxide semiconductor, and all these layers are different, or they are separated by what is called as an insulator, and this insulator acts as a dielectric. You very well know this, this has been explained previously. So, what happens when you have different layers of some thickness and length? They are seen as a sheet, okay, and each sheet will have some resistance, and that resistance is termed as sheet resistance. We are supposed to know how to calculate the sheet resistance, and since your conducting and semiconducting layers are separated by an insulator, this insulator acts as a dielectric. There is a formation of a capacitor in between your layers. Okay, we need to see how to calculate what is the value of this capacitance, and that is called as your Cg, that is your gate capacitance. First, let us start with sheet resistance. Sheet resistance Rs. Okay, as I had told you, we are seeing the layer as a sheet. Okay, this will be the length of the layer, this will be the thickness of the layer, and this will be the width of the layer, and each layer, because they are made up of different materials, they will be having some resistivity. We are going to calculate what is the resistance of this layer A, B. Okay. See, from the basic definition we know that resistance RAB is equal to rho L divided by A ohms. This is the standard definition of your resistance, and since we are talking about the cross sectional area, A is nothing but the cross sectional area. Cross sectional area. So, what is A here? It is thickness into your width. So, RAB is equal to rho L by TW, and let us take the case where L is equal to W. So, what happens to your RAB? RAB will be, since both are equal, they get cancelled, rho by T ohm per square. This is nothing but equal to your RS, termed as sheet resistance. Madam. So, let us take some examples and see how to calculate the sheet resistance. Let us take the first example, wherein I have my transistor. This is a poly, and you all know that crossing, this will be your transistor. This is 2 lambda, this is 2 lambda, this is the length, this is the width. Okay, this is one transistor, and before that let me give you the standard value of RS for a 5 micrometer technology. If it is an NMOS, your RS value will be 4. RS value will be 4. If it is a PMOS, it will be 25 kilo ohm for 5 micrometer. This is 4 kilo ohm for my 5 micrometer. This will be 25 kilo ohms for PMOS. This is the standard value. With this standard value, a dimension is given. We are supposed to find out how much is the RS. So, how do we find that? R is equal to 1 square into RS, the standard. What do you mean by 1 square? 1 square is nothing but your Z into RS, that is L by W into RS. What is L? Both are 2 lambda by 2 lambda into RS. So, this is 1 into RS, and we know what is the, because this is a NMOS, okay, it is 4 kilo ohm. So, it is 1 into 4 kilo ohms. So, this is 4 kilo ohms, or this is 4 into 10 to the power 4 ohms. Okay. So, this is one. Let us take the resistance calculation for an NMOS inverter. So, resistance calculation for NMOS inverter. Okay. You all know how to build an NMOS inverter. It consists of a depletion mode transistor as a pull up and one enhancement mode transistor, and the gate is connected to the output. This will be my output, this will be my VDD, this is my input, this is my ground. The ratio of this transistor is 4:1, this is 1:1. This is your pull up transistor, this is your pull up, this is your pull down. So, first let us calculate for pull up transistor. So, you all know R pull up will be equal to Z pull up into RS. How do you calculate Z pull up? Z pull up is equal to L pull up by W pull up. So, that is nothing but 4 divided by 1, that is 4. Substitute here. So, R pull up is equal to 4 into, this is 10 to the power 4. Sorry, I made a mistake here. The mistake is, this is 10 to the power 4. So, this is 10 to the power 4 ohms. Okay. So, this will be 4 into 10 to the power 4 ohms. This will be for pull up. Next, for pull down. Pull down, the same thing, R pull down is equal to Z pull down into RS. Z pull down is 1 by 1 L by W into RS. So, this is 1 into 10 to the power 4, that is 10 to the power 4 ohms. Okay. If they ask you to find the on resistance, on resistance will be the combination of these two resistances, pull up and pull down. So, that is R pull up plus R pull down, that is 4 into 10 to the power 4 plus 10 to the power 4. So, that is 5 into 10 to the power 4 ohms, and this value 10 to the power 4 is standard value for your 5 micrometer technology. As the technology changes, the sheet resistance also changes. And what is your off resistance? Off resistance will be only pull up, that is 4 into 10 to the power 4 ohms. Next, we will see how to calculate resistance for a CMOS inverter. Here both were continuing with the CMOS inverter. CMOS inverter will have one PMOS and one NMOS. You are all aware of this. This is the ground, this is your VDD. So, you are giving input here, you are taking the output here. Ratio given is 1:1, 1:1. Okay. So, now first let us find out for the pull up transistor. This is your pull up transistor, this will be your pull down transistor. For pull up, so for R pull up, it is Z pull up into RS. Z pull up is nothing but L pull up by W pull up into RS. So, this is 1 by 1 into 25 into 10 to the power 3. This is the standard value for PMOS, standard value, RS standard value for your PMOS. So, this will be 25 kilo ohms. Okay. Next, for pull down, R pull down will be equal to Z pull down into RS, that is L pull down by W pull down into RS, that is 1 by 1. This is an NMOS. The value, the standard resistance value, sheet resistance value is 10 to the power 4. So, this will be 10 to the power 4 ohms. Okay. What is on resistance? On resistance means like when this particular transistor is on, output node is going to get charged to VDD. So, that is the time when only PMOS is conducting. So, on resistance will be same as your R pull up, and off resistance means pulls your output node ground by NMOS. So, that will be your R pull down. So, this is all about sheet resistance.